Hello, Algebra 1 peeps. We are going to graph our quadratics written in standard form. And here we go. So quadratics written in standard form take the form of y equals ax squared plus bx plus c, where a, b, and c are different numbers. Okay, so then specifically we're going to graph y equals negative x squared plus 4x minus 1. So step 1, when graphing our quadratics written in standard form, we need to identify if the parabola is going to open upward or downward. And how we can tell by looking at the quadratic written in standard form is if the x squared is positive or negative. So the coefficient of x squared is negative, which lets us know that we are going to have a downward opening parabola. So that a is negative, so we know that our parabola is going to be opening up downward. Next, we're going to actually find and draw our axis of symmetry, and we need to use this formula. This formula, x equals opposite b over 2a. This is key. To find the axis of symmetry, we need this equation, x equals opposite b over 2a. Notice how I said opposite b, not negative b. And you're probably thinking, where is this b and where is this a coming from? Well, in standard form, we have ax squared plus bx plus c. So our a, b, and c is already in our equation. So we identify that as a equals negative 1, b is 4, and c is negative 1. So we're going to substitute our values of a and b into our equation. So we have x equals negative 4 over 2 times negative 1. So we simplify this expression. We have negative 4 divided by 2 times negative 1. We get negative 4 over negative 2, or negative 4 divided by negative 2. Simplified further, we have x equals 2. So then our axis of symmetry, x equals 2 is not a point on just 2, it's actually a vertical line, a dotted line specifically, at x equals 2. That is our axis of symmetry. So then, when we draw it, we find on our x-axis where 2 is, right here. And it's not just a dot, but it's a vertical line going up and down where x equals 2 at all times. Boom. Did that really fast. If you want to see that in slow motion, I can do that for you. I guess that's a little slower, but whatever. So there's our axis of symmetry. Step 2 done. So we've identified if the graph opens up or down. With the negative sign, it's opening downward. After you identify that, we found the axis of symmetry using x equals opposite b over 2a. Now we have to plot the vertex, and we need step 2 in order for us to plot the vertex. So we did step 1, step 2, plot the vertex, step 3, and this axis of symmetry lets us know not only where our line of reflection is, but it lets us know that our vertex is somewhere on this line. We already have one of our points of our vertex, 2. So to find the corresponding y, all we have to do to find the vertex is substitute 2 into the x of our equation. So then we're going to take our equation, y equals, so then we're going to substitute in our 2, negative 2 squared, negative times 2 squared, plus 4 times 2, minus 1. So simplifying further, we get negative 4 plus 8 minus 1, 4 minus 1, y is equal to 3. So our vertex is at 2, 3. So notice how when we plot that, we're over 2 on the axis of symmetry. Now we're going up 3. 1, 2, 3. Boom, there's our vertex. Okay? So we've completed step 1, opening or identifying if the graph opens upward or downward. Step 2, finding the axis of symmetry and then drawing that on our coordinate plane. Step 3, using the x-coordinate of our axis of symmetry to find the y-coordinate of our vertex, and that becomes our vertex, and we plot it on our coordinate plane. So now the final step is that we're going to plot 2 points, and we're going to use the axis of symmetry to get the 2 additional points. So here's what I know. I know my vertex is at 2, 3. and I know that it's opening downward. So my graph is going to open up this way. So then I'm going to select 2 points, and how I know what points I'm going to pick, I'm just going to pick 2 points to the left of my x. So we're at x equals 2, so I'm going to pick 1 and 0, and I'm going to make a t-chart. So I'm just identifying my vertex. So on the right side, I'm going to select my x's, which is 0, 1. So I pick those points because it's to the left of my vertex, 0, 1. So I have to figure out what my y is going to be. So all I have to do is substitute in 0 into my equation to figure out what the corresponding y is going to be. And I'll do that up here. So y equals negative 0 squared plus 4 times 0 minus 1. Y equals 0 plus 0 minus 1. So then y equals negative 1 when x is equal to 0. So I'm going to do the same thing for 1. So I did the same thing. I plugged in 1 into my equation. I end up getting 2 for my y. So when I plot these points, 0, negative 1, it's right here. And when I plot 1, 2, it's right there. So then I have 2 points, but then I need 2 additional points after that. And that's where the axis symmetry actually comes into play. I can use this line to mirror 2 additional points. So I should have a point, see, for this point 1, 2, I should have another point at 3, 2, because it's exactly 1 unit away from the axis of symmetry, so I should have another point here. And I should have another point at 4, negative 1, because at 4, negative 1, we're 2 units away from the axis of symmetry. So then my next point, I'm 2 units away from the axis of symmetry, and I'm going down just to mirror my original point. And now I graph it. Beautiful. Okay, so this is how you graph a quadratic written in standard form. Make sure you follow these steps, and this is a foolproof way to graph all the different components that's necessary to graph a quadratic in standard form. Alright guys, in example 2, now we have to identify if the quadratic has a maximum or minimum value. So the first step is to identify if it has a minimum or maximum. So that based on that alone, we have to decide if it opens upward or downward. So we're looking at the first term, 5x squared. So the coefficient of x squared is a positive 5, which means that we are actually going to be opening upward. So since a is positive, we have an upward opening graph. Okay? So if we have our makeshift coordinate plane, we know that it's going to open this way. So that point right there, our vertex, we're identifying if it's a minimum or a maximum. So if you look at all of our points, the lowest point is at our vertex. So because it opens upward and our lowest point is down, our vertex, this function, has a minimum value. So once we've identified that it has a minimum value, now let's actually find that minimum value. And we're going to use the equation from before, opposite b over 2a. So we're going to find the axis symmetry, so exactly where it's at. And we know that a is equal to 5, b is equal to negative 20, and c is equal to positive 17. Substituting our values, we have negative, or opposite negative 20, or divided by 2 times 5. So we should get 20 divided by 10, x equals 2. That's the axis of symmetry. That's not our minimum value. Our minimum value, because we're talking about height, we need the y-coordinate of our vertex. So we have to go through the steps of finding the axis of symmetry using that exact point of x to figure out where that y-coordinate is going to fall to identify as our minimum. So using our quadratic, y equals 5 times 2 squared, we're going to substitute our 2 into our original equation and simplify. So then we get negative 20 plus 17, simplified further, our y is equal to negative 3. Our minimum value is at negative 3, where our vertex is at 2, 3. That y-coordinate of our vertex is our minimum value. And we know it's a minimum because it opens upward. It's our lowest point in our parabola. Boom, done. Let's call it a night. If you have any questions, make sure you write them down on the side. It's very, very important that you are listening to the videos versus just watching them without any audio cues whatsoever. Alright, thanks.